Good morning, guys. Our topic today is all about feedback mechanism and its role in homeostasis. We are going to start off by defining homeostasis and showing you this guy. And defining, by definition, it's when the internal conditions are balanced and it maintains the system in normal range. We have very basic examples here: body temperature, pH range, and glucose level. Let's start off with body temperature. Let's say temperature outside is very hot or very cold. Inside our body, we are warm-blooded. So that means regardless of the changes or temperature variations on the outside, our body is able to keep that level of temperature that will keep us alive. That is homeostasis. Same way with pH level. There's only a certain level of acidity or basicity that our body would like to be in, and therefore, if that goes beyond what our body wants, our system will have to make certain adjustments. And common systems that would make these adjustments are respiratory system and also the kidney, the excretory system. The third one is glucose level. Every time I eat, I drink anything sweet or has sugar, my glucose level will go up. I can't keep my glucose level going up or else I'm going to be sick or I could die. So in order for me to stay alive and not be sick, my body has to do all those changes to make me in homeostasis. How does homeostasis look like? It basically looks like this graph. If you pay attention to the gray line that is labeled set point, I'm putting the cursor to it now. So this is the gray line, it's straight, and as you can see, it's labeled set point. That is homeostasis. It's flat, stable, okay? Very basic. What about the blue line? The blue line, which shows you going up and down, it does not necessarily need to be this height. It can even go up or it can even go lower, but it has to be a going up and down between that range that will show you the set point. This blue line is what you call the feedback mechanism. So what is feedback? From the word itself, feedback, it's how our body will respond to any change. And it's very important. So feedback is the one that will actually make all the changes in order for our body to stay in homeostasis. I hope that's very clear. And if not, let's take a look at how feedback mechanism is really like in relation to homeostasis. If you look at the whole figure here, it's there's so many labels. We'll try to keep it simple for you, and I have labeled the parts according to what are the components of the feedback mechanism, beginning with the first part, which is the stimulus. Stimulus is any message. So it's a message that can be coming from the outside the body or the inside of the body. Common example of a stimulus coming from the outside the body, perfectly the light. You can see the light. You can also hear some noise. You can feel some touch. Those are stimulus coming from the outside. Stimulus coming from the inside could be pH or could also be the sugar in the blood. A stimulus or stimuli, plural, will always cause a change. In order for that change to happen, which you will see over here, it has to pass several steps. So the second step will be, excuse me, the receptor. So what is a receptor? A receptor is a protein molecule. And as we've learned from first term, protein works according to shape. So this receptor molecule that's found on every cell of the body will receive the message. Or in short, receptor receives the stimulus. Let's go back to our example, light. If the stimulus is the light, bright light, the receptor will be found on my eyes. So my eyes, the cells on my eyes would have the receptor to receive the message bright light. Third step of the feedback will be the control center. So what's a control center? Control center is the part of the body that processes all the information, and this control center includes the spinal cord and the brain. Let's backtrack a little bit. Stimulus is the bright light received by the receptor on the eyes, and the message travels through the nerve cells to the control center, the spinal cord, and the brain. The brain will process that information, and once the information is processed, it will now tap onto the fourth part of the feedback, which is the effector. Effectors are parts of the body. It could be a muscle, it could be a gland, or it could be any organ that will try to complete the process and will give you the final step, which is the response. Backtrack again. Stimulus is bright light. The receptor is receiving the information are on the eyes. The message traveled to the control center, which is the spinal cord and the brain. Brain processes the information, and brain sends the response to the effector. There could be many effectors. There could be more than 1, 2, or 3, or even more than 3, and all acting at the same time. So I'll give you one example. The effector could be the muscle on your eyes or the eyelids, and the response will be to blink. So bright light, you blink. Or it could be the muscles on your arms and on your hands. The control center may send the message to the effector, your hands or muscles, your arms, to cover your eyes. Covering your eyes is the response. Or it could be both. It could be blinking and covering your eyes at the same time. So those two are the responses. Let's think of another example, and later I'm going to ask you to think of your own. So let's say you hear a sound. The sound could be your mom calling you, right? So the stimulus there is the sound of your mom's voice calling you for dinner maybe. The receptors are found on your ears. You hear your mom's voice, stimulus received by the receptors on your ears. And the message traveled to your spinal cord and to your brain, processed by the control center. And the control center will pass on the processed information onto the effectors. Again, there could be more than one effector acting at the same time. So let's give one example of an effector. It could be your neck muscle, or it could be your vocal cords, or it could be your arm, your hand, or it could be your head, the muscles on your neck, or it could just be your eyes or other parts of your body, right? Legs. What type of response would you give if you hear your mom's voice? That's the question, right? Depends perhaps what she's telling you. But if she's inviting you for dinner, the effector or the brain may process the information like you getting up from your feet and walking towards the dinner table. So where's the effector there? The effector in that case will be the muscles on your legs, and perhaps also on your arms, and perhaps also on your vocal cords, saying or responding to her, saying, okay, I'm coming, mom, right? So those will give you altogether how the effector will give the response. Basically, this whole picture here helps you complete the cycle of feedback to achieve homeostasis. There are two types of feedback. We'll make it simple. The first one is positive feedback. Positive feedback, let's assign a symbol here. Let's assign this one as a plus sign, plus, okay? And then this box here, a plus sign also. So which means more interest earning, account balance grows. So they're both increasing, okay? It's simply saying if it's bright, I'm going to make it even brighter to achieve balance. Another example will be if it's cold, I'm going to make it colder to get where we want to get, like a balanced environment. Another example will be maybe pain. We need more pain to achieve homeostasis. A perfect example here will be childbirth. Okay, a woman ready to deliver a baby Having contractions is feeling pain, tremendous amount of pain. And what's causing the pain basically is the baby that needs to come out, right? So if there's pain, in order for that pain to go away, there needs to be more pain. And where is the pain coming from? The pain is coming from the contractions. So more contractions will cause that pain to increase, more pain. So plus, plus. If there's more contraction, the baby will be forced to come out. And once the baby is out, that's when the mother will feel a lot better. So she's going to be in homeostasis. So again, let's recap. It's pain, more pain, so that the mom will achieve homeostasis. Now, the second example will be a negative feedback. It's the exact opposite. In this example, you're going to see a body temperature rises. In order for that temperature to go down, the body has to respond to something. The body has to act on something. So plus, minus. Example will be thermoregulation. Basically, this whole picture here is thermoregulation. Thermo means heat, regulate means control. Another example will be glucoregulation, how we control the level of sugar in our blood, and then water regulation, and then stomatal opening, closing, which we'll all talk about in our next lesson. Let's focus on glucoregulation. When I eat anything, my sugar level will go up. So the stimulus is the sugar, and then it will now go to the control center. Control center in my brain will now send the response to the process information to the effector. The effector in this case will be the pancreas. Pancreas will release a hormone which is called insulin that will lower the sugar level in the blood. Lowering the sugar level in the blood is now the after effect of the response, which is the release of insulin. So that's the end of our lesson today. Just a couple of reminders. Tomorrow we have lab, and the lab tomorrow is all about cell respiration. We're going to be using yeast, and it's going to be included in your homework that you can see on your stream, same way with CFU. Have a good day, everyone.